Okay, so now we're going to go over those answers to the review questions for chapter 1 and 2 test. In other words, our test 1. Work is not always shown, but I'll summarize what you're seeing in front of you to help you out. So for number 1A, the sum of the x's just means add up the following values, the x values, 7, 3, 9, 5, and 4. When you do that, you get 28. Then this one, it's very important you notice the parentheses. This says to take the sum of the x's and then square it. It does not say to do the x's squared and then add them. That's the import of the parentheses. Letter C says square all the x's, then add them. See the difference in that parentheses there? So for letter B, if you take the 28 that they all added up to and then square them, you get 784. For letter C, if you square the 7, get 49, the 3 to get 9, the 9 to get 81, and so on, and then you add them up, you will get 180. The sum of the x's and the 5's. That means you go to the sum of the x's, which is up here in part A, that was 28, and you add 5, and you get 33. There's a big difference between letter D and letter E. In letter E, with the parentheses, you have to subtract 2 from each of these scores, and then add them up. So 7 becomes 5, 3 becomes 1, 9 becomes 7, 5 becomes 3, and 4 becomes 2. Then add them all up and you will get 18. Okay? The next question is a frequency distribution table, then to sketch a histogram and a frequency polygon. So here are the scores, okay? Real limits really only have to do with the purposes of the histogram. And this is the frequency or the number of each. As far as getting the proportion, if you will, that's just a matter of doing the total number of scores. You have to figure that out right away, and that would be 6, 11, 14, 16, 17, 19, 20. There are 20 total scores. So the frequency for the first one is 2 out of 20. 2 out of 20 is 0.10. For the next one, it's 4 out of 20, which is 0.20. For the next one, it's 5 out of 20, which is 0.25. So in other words, to get the P, the proportion suggests fraction, it's the number in the frequency here, 2, 4, 5, and each time you're going to divide by 20, okay? That gets you a decimal. To convert to a percent, we move 2 places to the right. Cumulative frequency, extremely important. We start with the lowest score, and we just add the frequencies up as we go along. I have 1 score between for 1. Then I go and add the 2 scores for 2 to get a total of 3. There's 1 score for 3 to get a total of 4. Then there's 2 scores for 4 to get a total of 6. 3 scores gets me to 9. 5 scores gets me to 14. 4 more to 18 and 2 more to 20. So that's how we get the CF, or the cumulative frequency column. Number 2, this time we want to do a grouped frequency distribution. Here's where real limits become more of a matter of purpose. Oh, there is no histogram. I don't know why she drew a histogram here, but basically a histogram where the bars touch each other. Label the axes and make sure each bar goes as tall as the frequency. Okay? So over here, the midpoints is what we use for calculation purposes. The midpoint will be in the middle between 25 and 29. So the midpoint is 7. The midpoint here would be 22. The midpoint here would be 17, and so on. The 20 scores are listed below, and they're fit into these. Here's your midpoints on the left. They're fit into these real limits, okay? By putting real limits, all we're doing is we're making sure that everything fits into a category and nothing fits into 2 categories or intervals, okay? Sorry about my dogs going nuts out there. We got some guys doing work on the house. Now Gibbs is starting to howl. Hey! The minis inside don't even hear me. Okay, you can take a look at the table now to see where it's filled out. The big thing is there are 5 scores between 15 and 19, 9 scores between 10 and 14, 4 scores between 5 and 9. Again, to get the P, or the proportion, you take and divide by the total number of scores, which in this case, 6, 8, 10, 12, 14, 16, 20. So you're going to do 1 divided by 20 is 0.05. 1 divided by 20 again. 5 divided by 20 is 0.25. 9 divided by 20 is 0.45. Convert to a percent, move 2 decimal places to the right, and accumulate the frequencies as you go along. You got 4 here, then you got 9 more here for a total of 13. 5 more here, 18. 1 more, 19, or 1 more, 20. Okay. All right. Next up, stem and leaf plot. Use a stem and leaf plot to organize the data. Notice I'm not comfortable with how this is. A stem and leaf plot should have these ordered, and you're expected to order them when you do your test. There is one question where you're asked to create a stem and leaf plot. This answer is incomplete. 6-3 is good, but it should then say 7, and it should say 1, 4, 7. 1, 4, 7. We should put them in order. For 8, it should say 1, 2, 4, 4, 6. Back down to number 11 should say 7, 8. So make sure you put them in order every time. If they're not in order, it is not fully correct. It's kind of like scratch work if it's not in order. Okay, vocabulary-based questions. These are, the math on this stuff is real simple for me. And some of the vocabulary is pretty simple, but some of it can really be annoying. Researcher uses an anonymous survey to investigate the study habits of American college students. Based on the 56 surveys that were turned around, the researcher finds that these students spend an average of 4.1 hours per week. For this study, the average is an example of, and it's a statistic because it's based on the surveys. Remember, PPSS, parameters come from the population. Statistics come from the samples. And this is 56 students are a sample of all of the American college students. Researcher is interested in the eating behavior of rats and selects a group of 25 rats to be tested in a research study. The group of 25 rats is a sample. Again, you start with this big population. I'm sure they had more than 25 rats in the place, and they selected a group of 25 to study. So the population is all that you have to choose from, everybody. The sample is a subgroup or a subset of the population. Okay, it's very important. There will be a question on your test where you're asked to differentiate between population and sample. Although a research study is typically conducted with a small group of participants known as blank, most researchers hope to generalize their results to a larger group. See, that relatively small group is the sample, because the sample is a piece of the population, and then they want to generalize those results to the entire population. And that's where, if you do a really good job, there's minimal sampling error, and if you're off in your sample, you get sampling error, which is a problem. Okay. Statistical methods that organize, summarize, or simplify data are called, in this case, they are called descriptive statistics, because all they're doing is describing the data. Which of the following is an example of a discrete variable? And I got to tell you, this right here, this is the questions that drive me crazy, because I don't feel like I personally am always rock solid on the difference. And part of the reason is, in preparation for this, I went back and I reviewed discrete, continuous, so on and so forth. And I knew that continuous talked about, you could always continue to break it down, break the variable down more, or the thing you're talking about, be it time, weight, etc., infinitely divisible. But it also said very specifically on some of these sources that gender is never a discrete variable. Yet here it is, a discrete variable. I think this is one of those, and this is what can drive anybody crazy in any course. It doesn't have to be math. It's one of these, which is the best answer. Okay. The age of a student, your age can break down. We say, okay, I'm 58 years old, but I could be 58 years in 1 day, or 58 years in 25 days, and then I could be 25 days, 5 hours, 5 minutes, and so on and so forth. The amount of time needed to solve a problem. Again, you can break down time. Age is a form of time. And then the amount of weight gained for each freshman at a local college. Again, you can break weight down, weight, ounces, and so on and so forth. Or you could go kilograms, grams, decigrams, centigrams, and so on and so forth. You can keep breaking it down. You can't do that with gender. So gender is not continuous. and it's the best answer out of those four. Okay, which of the following is an example of a continuous variable? And that's kind of the flip side of what we just talked about. It's the amount of time to solve a problem, because time can be continued to break down, whereas gender cannot be broken down anymore. Number of males in each class offered by the college. Number of males, you can't be a half a male, you can't be a quarter of a male, you can't break down males, and you can't have a half a kid. All right, so the number of children in the family is also definitely a discrete variable. Determining a person's reaction time in milliseconds would involve a measurement of what scale? That would be ratio, okay? Generally speaking, time is going to be ratio. There is a definite zero, and it can be broken down. Determining class standing, that's order. Order is short for ordinal, or I should say ordinal is short for order. And whenever you're placing things in order, you're looking at ordinal. There are, I want to say two, maybe three questions about, no, there's two questions I think about levels of measurement and discrete continuous on your test. Then you get into a number of questions like this on your test. What's the total number of scores? Well, the total number of scores is going to be all the frequencies added up. I don't care about what the score is. I care the number of scores. So if there's 3, 5, 4, and 2, that means there's a total of 14 if you add them up. This one says how many individuals had a score of 2. Well, here's a score of 2. And this is saying that 3 individuals had a score of 2. You know, it's a very basic skill that on your test you're going to need to be able to interpret frequency on a few different occasions. It might not be the whole answer to the problem, but it will certainly be part of the answer to the problem. For the following distribution, how many people had scores greater than 14? If you're greater than 14, then you're either 15 to 19 or 20 to 25. There are a total of 7, 2 different intervals, and 5 and 2 adding up to 7 total scores. You will have a question like that on the test as well. For the following distribution of quiz scores, if a score is 3 or higher, and if it's needed for a passing grade, how many individuals passed? Well, the number of individuals passed would be, you need a 3 or higher, so that would be 6 and 5 and 5. 3 is passing, so that's a total of 16. The scores below stem and leaf plot, what's the highest score in the distribution? And this is exactly why you put things in order, okay? The highest score is 84, okay? All right, ages of the signers of the Declaration of Independence. Is it grouped or ungrouped? I'm not exactly sure where this is coming from here. I guess when she did this, she put it into a table. I didn't see a question earlier. I'm sorry if I missed it. But here's a look at what the table comes out to. Okay. Oh, construct a frequency distribution for the data. I missed that. Here's your frequency distribution right there. Okay, so that's a review of the previous worksheet and a video for that. Have a great one.